Today we're going to talk about functions and their domains. Now, with arithmetic, add, subtract, multiply, divide, we can pretty much do anything we want. But there are two issues we run into that create either answers that are not real or answers that simply don't exist. Do you guys know what those two things are? What are you not allowed to do with addition, subtraction, multiplication, and division? You're not allowed to, you can add any two numbers together, right? What about subtraction? Can you subtract any two numbers? What about multiplication? What about division? You can't divide by 0. And that's not totally true. When you get to calculus, you'll divide by 0 all the time. It's either infinity or negative infinity. But neither of those numbers are real numbers. Okay? And actually, there's one more thing you're not allowed to do, and it falls in the realm of multiplication, which is square roots. What are you not allowed to do with square roots? You cannot square root a negative. Now, we do when we solve quadratics and we get imaginary numbers, but a graph cannot display either imaginary numbers or infinity. So the two things we can't do is divide by 0 and square root a negative number. There is one more category which deals with logarithms, but that's not for several chapters down the road. So for today, all we have to worry about is dividing by 0 and square rooting negatives. Okay? So if I had the square root of x plus 3, are there any numbers I can't plug into that equation? I can plug in 3, negative 3. And actually, negative 3 does work. So if I say, what happens when x equals negative 3? Plug it in. The square root of negative 3 plus 3 is the square root of 0. Does that exist? It's just 0. And that actually worked. Can you think of a number that won't work? Negative 4, right. X equals negative 4. The square root of negative 4 plus 3 is the square root of negative 1, which is I. And if you plug a number in and you get an I, that original number is not part of the domain. Okay? So what's the biggest number we can't plug in? Well, okay, I guess I need to define big, right? What's the number that's furthest to the right that I can't plug in? What is there one closer to 0 than negative 4? Negative 3 worked. Would negative 3.5 work? No, why not? It's further away from 0 than negative 3, right? It's to the left. Okay. What about negative 3.1? That's not going to work. What about negative 3.00001? So when we say bigger, we usually mean further to the right. That is a little bit confusing because you could have a bigger negative. But the largest number is actually whatever number is right next to negative 3. And there is no number right next to negative 3. Because you could say negative 3.1100000001, or you could have 8 zeros and a 1, or 12 zeros and a 1. So how do we represent everything that is smaller than negative 3? You would use, so you'd say negative infinity to negative 3 doesn't work. Do we want to include negative 3 in the piece that doesn't work? So it'd be this is a no, and this is a yes. What do I use for symbols on that one? A bracket. Right. Negative 3 does work, but everything smaller than negative 3 does not work. Okay? So this stuff is not part of the function, and all of this is, and that is the domain. Now graphically, it's going to look like this. -1, 2, 3, and the graph looks like this. Okay? There is no graph to the left of -3. Does everybody see that? There is nothing over here. Why is there nothing over there? Because when you plug in any of these x values, you're going to get an imaginary number. And we can't graph imaginary numbers in the xy plane. Okay? So that's one way to break a domain. The other way is something like this. Are there any numbers I'm not allowed to plug in? 1. What happens when I plug in x equals 1? I get 1 over 1 minus 1, which is 1 over 0, and that's infinity, or negative infinity. Okay, can we graph infinity on our xy axis? We can draw a line that goes in that direction, but we can't actually get there. So this graph looks like this. Okay. And if you plug in x equals 1, there is no spot on the graph that touches. Okay? So if I try to plug this in, I miss. And that's a vertical asymptote. We'll talk more about that in the future. Okay? What if I had this? Actually, let's do this. Okay. What numbers am I not allowed to plug in? 0 is actually okay. 1 and -1. How come? Those are the roots of the denominator, right? Set both of these equal to 0. And I know x is not allowed to be -1 because it will break this piece. And it can't be 1 because it will break that piece. And this graph's a little bit weird, and we're not going to get into it too much, but I have a vertical asymptote here. So the graph is going to look like this. Hang on, let me do that a little bit better. Do you guys remember those from last year? It's okay. We'll go over it again. But notice there is no graph at -1 because it shoots off to infinity. There's also no graph at +1 because there is, what did we call those? A hole, which means the graph jumps right over that piece. And if you graph this in your calculator, you won't see the hole. It doesn't show up. But as we calculate all these points, I go all the way down and I get really close to 1, and then I jump over it, and then I continue to graph. But in both cases, I am not allowed to plug in those two numbers. Graphically, sometimes it looks like a hole, and sometimes it looks like a vertical asymptote, and that's not for today. All we need to do today is figure out which numbers work and which numbers don't work. Okay, what if I had the square root of x minus 4 over x minus 6? What can you tell me about that graph? And of course, I need to write y equals on all these, but 6 doesn't work. X is not allowed to be 6. Okay? And then for this piece, whenever you have a square root and you want the domain, there's a really easy way to do it. Whatever this is, right? In every square root, what do I know about that number? It has to be 0 or bigger, right? If it's smaller than 0, then I get an I. So whatever is inside a square root has to be greater than or equal to 0. So all I'm going to do is take this stuff, x minus 4, and write greater than or equal to 0, and then solve it. How do I solve x minus 4 is greater than or equal to 0? Add 4, and I get x is greater than or equal to 4. So what's the domain in interval notation? It's not actually 4 to infinity because of this. 4 to 6 union with 6 to infinity, and then we just have to figure out the symbols. The left side of the first one is a bracket. Why? Because I have an equal to right there. The 6 would be a parenthesis because 6 doesn't count. And the second 6 would be a parenthesis, and infinity always gets a parenthesis. But it's not 6. It's not equal to 6. That's why the reason those are parentheses is because 6 doesn't count. Okay. The other way to do it, you could do this, bracket 4 to infinity, and then say x is not allowed to be 6. But that's probably not the way it's going to show up on a test. So, but that technically is also correct. Everything here except 6. Okay? All right. What about the square root of x squared minus x minus 6? Well, let's factor that out. X minus 3 and x plus 2. Okay. And I want to know, when is that greater than or equal to 0? Well, let's look at the graph. What does the graph of x minus 3 times x plus 2 look like? Well, the roots are 3 and negative 2. So negative 2 here and negative 3 here. How do I know it goes up? It's positive x squared. When is that graph bigger than or equal to 0? Negative infinity to negative 2. Does negative 2 count or not? Yes, because it is 0. So that's a bracket. Union with 3 to infinity. Like that. Hey, that's kind of a hard one. But you just want to know, when is that graph on the x-axis or higher? Okay. What if I had... Oh, let's do this. Here I want to make sure that this stuff is 0 or bigger. So 4 minus 2x has to be greater than or equal to 0. Subtract 4. Negative 2x is greater than or equal to negative 4. Divide by negative 2. And I get x is less than or equal to 2. Why do you have to flip the inequality? I divided by negative. Now, somebody told you that a long time ago, but they never explained to you why that's the case. Right? No, I'm going to. Okay. Why, when it's an inequality, do you have to flip the inequality when you multiply or divide by negative? Here's why. Let's say I had 2x plus 3 equals, let's make this easy, 11? 11. No, that's too much. Let's do 7. So this is a balanced equation. On one side, I have 2 blocks that are x, and then I have 3 1-pound weights. On the other side, I have 7 1-pound weights. Okay? Well, if I want to solve for x, I can do anything I want as long as I do it to both sides. So what am I going to do? Get rid of 3 1-pound weights on the left, and in order to maintain balance, I have to get rid of 3 1-pound weights on the right. It's still balanced. Now I have 2 x's are equal to 4 pounds. So how do I solve for x? Well, I get rid of half of my x's, divide by 2. And on the other side, I get rid of half of my weights, and now I have 1 x pound. 1 x is equal to 2 1-pound weights, and the answer is 2. Okay? Well, what if I had 2x is equal to -3? Let's do -6. Okay? Well, this is a little bit strange. Over here, I have 2 x's. I don't know what they're doing. And on the other side, I don't have 6 weights. I actually have 6 1-pound balloons. Right? And the balloons are pulling up. Does that make sense? Okay. So the x's must also be pulling up. How hard is the x pulling up? 3 pounds per x. Okay. Now, if I multiply this by -1, so actually these are going up. We didn't know that when we started. If I multiply the whole thing by -1, now these are going to be pushing down, and these become weights, and they're pushing down. Is it still balanced? Yeah. Whether you're pulling up at the same or pushing down at the same, it's going to remain balanced. Okay. What about x plus 3 is greater than 4? Is this balanced? No, it's not. What do we know? The x plus 3 weighs more than the 4. So now, this is what I have. How many ways are there to build that? And it's not 5, it's going to be 1. Well, it's this. Sorry. It's anything bigger than 1 to infinity, right? No, a bracket would equal 1. If x weighs 1 pound, is it going to be unbalanced? If x weighs 1 pound, it's perfectly balanced, right? But as soon as x weighs a little bit more than 1, now we're out of balance. Okay? So how many answers does this have? An infinite number. Okay? It could be anything from bigger than 1, so 1.1, 1.01 to infinity. There are an infinite number of correct answers. Okay? But if I times this whole thing by -1, so now I'm going to turn this into a balloon that pushes up, and I turn this into 3 balloons, and I turn this into 4 balloons. What happens? Which side is pushing harder? The left side is, right? It used to be, this side was anywhere from 4.1 pounds to infinity. Okay? So in the original problem, the left side is pushing down harder than the right side. But when I multiply by -1, Now my negative weight or my positive weight becomes negative weight, and that's going to flip the whole inequality from one side to the other. Now that's a really long explanation, but when the left side is heavy and you change the weights into balloons, the inequality is going to switch. And that's true anytime you multiply or divide by a negative. Why? Because it rearranges the effect that the weights have on the equation. We don't care if it's an equality, because if your down weights are equal, you're balanced. If your up weights are equal, then you're still balanced. But when you are dealing with inequality, things that are not equal, then changing the style of the weights will flip the problem around. Okay, so what about this? All right. What is the domain of this equation going to be? Well, first, let's deal with this one. I know that 3x plus 6 has to be greater than or equal to 0. So I subtract 6 and I divide by 3. X must be bigger than or equal to negative 2. Okay? But I also know that this is not allowed to be 0. So I factor it. And I get x minus 4 and x plus 2. So x is not allowed to be 4 or negative 2. Okay? Now I have to put those two domains together. Right. This one says x has to be greater than or equal to negative 2, and this one says x cannot be negative 2. Who wins? The not equal to wins. One side said yes, the other side said no, so the answer is no. So negative 2 gets a parenthesis up to 4, and 4 gets, nope, 4 can't happen. 4 does not belong. So from 4 union 4 to infinity. Okay, and if you look at the graph here, I'm not sure what it looks like, but it would be something like this. So at negative 2, we have a hole, and we have a square root, but when we get to x equals 4, there's another hole, or something like that. So this one here, if you looked at the x-axis, would be from negative 2 over to the right. Okay, and this one says there's a gap at negative 2 and at 4. So to describe that interval, this piece is everything bigger than negative 2 and smaller than 4, and then this piece is everything bigger than 4. And you just kind of have to play it by ear. What if instead of negative 2, this was a negative 3? Can we have a hole over here at negative 3? No, it's not even part of the problem. So all that would do is allow us to include the negative 2. Okay? All right, let me look at your assignment and see if, oh, good old Alton Hassel cleaned up my desk. So 150. Oh, how nice. All right, 157. Oh, hey, we didn't do any of those. Okay, a couple more problems. What about 1 over t squared plus 9? Does the bottom factor? Well, kind of. T plus 3i and t minus 3i. But when does this quadratic hit the x-axis? If the roots are imaginary, it never hits. Looks like this. And if it doesn't hit, it has no real zeros. So this one, the domain, is all real numbers. There's no way to make the denominator 0, which, if you look at it, makes sense. T squared is a positive number, right? So what positive number plus 9 equals 0? None of them. So there's no way to break this equation. Okay, what if I just had the equation x squared minus 5x plus 6? What do we have to worry about in this equation? Nothing. Will the denominator ever equal 0? No, there is no denominator. Will we ever have to worry about square rooting a negative? There are no square roots, so this one would be all real numbers. Okay, let's do this. This is not a fourth root. You're right. This is a third root. Okay. Do I have to worry about cubed rooting negatives? No. Right? If I had the cubed root of negative 8, does that number exist? Yeah, the answer is negative 2. Why does that one work, but the square root of negative 8 doesn't? Right. Two negatives make a positive, but 3 make a negative. So this one is all real numbers. What if I changed it to that? Now I have the exact same problem I had with the square root, and I would say x minus 4 has to be greater than or equal to 0. So x is greater than or equal to negative 4. Oh, you're right. Positive 4. Thanks. Okay. What about this? Of what do I have to worry about here? I have to worry about square rooting negatives and divide by 0. So let's deal with the square rooting negatives first. 3x minus 9 has to be bigger than or equal to 0. Add 9. Divide by 3. X must be greater than or equal to 3. Oh, sorry, what? Did we divide or multiply by negative? Nope, we're good. Okay, Bailey, say that again. Oh, good. So this satisfies the square root issue. Okay, but I still have to be careful not to do that. Are there any numbers in this group that will make the bottom 0? 3. So it can't equal 3. So the answer is going to be 3 to infinity, like that. Yeah, so this will be your answer. What is the domain? Now, if you look here, this is the problem, right? We said 3x minus 9 is allowed to be bigger than or equal to 0, but because the square root is in the denominator, the equal 0 actually doesn't apply in this case. Okay, what about this? What do I need to worry about here? Do I need to worry about square rooting negatives? No, because third root doesn't care about negatives. So the only thing I have to worry about is this. What number makes the bottom 0? -1. X is not allowed to be -1, so what's the domain? Oops. Union with -1 to infinity. Does that help? The other way to do this is all real numbers, but x is not allowed to be -1. That's probably what I would write. Okay, let me look one more time, see if that covers everything. I think so. So we went, how far are we supposed to go? -51 to 85. Yeah, you moved the wrong one. We're actually going to go 81. Yes, 51 to 85 odd. So 150, 157. So the other one should have been 155. Okay. 155, 51 to 85 odd. Now, 83 and 85 are actually different problems. They don't have instructions, and sometimes the book does that, and it's a little bit confusing. So in 83 and 85, you're not looking for the domain. Just answer the questions that it asks.